9, and it's a pretty short chapter compared to some of the other ones we've had. Like chapter 2 was really hard, I thought. But chapter 9, it's kind of a hodgepodge of stuff too. So, chapter 9, review. The test is just front and back, okay? You can have your calculator for the whole thing, and your formulas will be on there. Or they might be on a separate sheet. I don't think I can fit them, okay? But this is what you're going to have to do. So 9-1 was all about permutations and combinations. So we had NPR and NCR, okay? And you need to know when to use which one. I'm not going to ask you what's the difference between them, anything like that, but you do need to know, do I use this one? Do I use that one? Bless you. So which one? So NPR, that's when order matters, yes? Order matters. Okay? And a lot of times you don't even have to use NPR. Not matter. Order doesn't matter over here for NCR. So like for example, let's say, I love to use this example. You have 10 runners in a race, right? 10 runners. And we want to know, in how many ways can they come in first, second, and third place? So first, second, and third place. So how many ways can these runners? Well, you can use NPR for this, which would be 10 P3. Or you can use the multiplication counting principle, which is the way I would probably do this, just in case I don't want to mix these up. I would do this. So there's first place, second place, third place, right? The counting principle works for a lot of good things. You're going to use that quite a bit on this test. So there's 10 runners that can come in first. Once the one crosses the finish line, then there's only 9, and then there's only 8. And those things are equal to each other, okay? And then multiplication counting principle works for things like if you have 5 shirts and 3 pairs of pants, and how many outfits do you have, you multiply them together, stuff like that. And CR, the order does not matter. So these are things like groups or committee. Do you think committee has too many letters in it?
Yeah.
Yes, too many repeats. It's weird. Groups, committees, stuff like that. When you don't care about order. So let's do those 10 people again. And let's say those 10 people, for example, 10 people on ASB, and we want to make a group of 3 of them to plan Sadie's. Who's going to Sadie's? Yes, me. I am too. I have to chaperone. And no, I don't even want to be there. I'll tell you why. I like dances. They're cute. You guys dance. It's adorable. I dance too, which isn't allowed, but I do it anyways. I just don't like how late it is. Like, I'm going to be going to bed after 11 o'clock that night. And that's going to be 2 nights this week since I'm going to Hamilton tomorrow night. Hamilton. Okay. Here we go. All right. For this one.
Did your kids stay up for you? Sorry.
Oh, no. No. They have strict bedtimes. 10C3. Okay? You would have to use 10C3. You cannot use 10P3. Because if I had Alice, Bobby, and Carol to be in this group of 3 out of all 10 ASB people, it's the same group as Bobby, Carol, and Alice. That's the same group of people, right? It's not the same order, but I don't care about orders when they're in a committee or a group. There's not like a vice president, president, secretary. That would be different. Then, yeah, you'd have to order them. Okay. Then make sure that you know how to use the multiplication counting principle. That one's really important. Counting. Okay, some examples of that would be, let's say that you want to find out how many zip codes there are possible. How many zip codes? Do you know what a zip code is? It helps to know what that is. If you ever question, like, what's a zip code, you can ask me. I won't make fun of you. Well, I might a little bit. But that's okay. It's worth it just to get the problem right. All right, how many zip codes are there? Well, there's 1, 2, 3, 4, 5 numbers in a zip code. Okay? But let's say I tell you that it cannot start with a 1. No, let's say 0.
0.
Yeah, cannot start with a 0. Actually, I think New York has zip codes that start with a 0.
Oh, is that why there are only 4 digits?
Yeah, I think so. But there's 0 and then, yeah. So there's actually 5. Okay, so that means how many numbers can a zip code start with then? 9 numbers. Okay? And then the next number, there's no restrictions on any of these, so they would all be 10. Because 0 through 9, that's 10 numbers, okay? But if I take one of the numbers out, there's only 9 options for the first one, and then you multiply those and it works. Now, something I did not do with you, which I probably should have, is how many different words? How many words can you make from...
Switzerland.
Ooh, I don't even know how to spell that, no. Let's see. Mississippi. Let's do it. That one everyone knows how to spell, right? You wouldn't think we would, but everyone, M-I-S-S-I-S-S-I-P-P. Okay, so what you want to do, don't even start. So what you want to do is you want to count them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to be 11 factorial. Now, that doesn't really work, though, because now I have to divide out the repeats. Because if I took these two S's and switched them, it's still the same word, okay? So I have to divide out all the repeats. So let me see. There are 1, 2, 3, 4 I's. I'm going to divide by 4 factorial. And then there are 4 S's. And then there are 2 P's. Okay?
What does the factorial mean?
Factorial means, like, for example, 4 factorial, it's not pronounced 4! Remember? Like an exclamation point. This is 4 times 3 times 2 times 1. Your vids are trash.
So they don't, they're not trash. So they don't have to be like logical words though, right?
No. Yeah, that's right. Sometimes they'll write words because they're not real words. Yeah. 4 times 3 times 2 times 1 is 24. And your calculator has that button, that factorial button on there. Okay, so that's just the first lesson. It's a big one though. 9-1 is like huge stuff. 9-2, I feel like most of you guys are pretty good at 9-2. It's the binomial expansion theorem. Maybe you don't know what that means. This is an Algebra 2 topic. Like algebra, we don't get to it in regular Algebra 2 here, but every public school around here is how you spell expansion. Doesn't look right, but I think it's right. This is if you have something like 5x plus 3y to the 4th power, and you have to expand that, okay? Now, if you want to, you can write Pascal's triangle on your paper and get that really quickly. You can also do 4c bracket 0, 1, 2, 3, 4, that with commas in the middle. That gives you the 4th row of Pascal's triangle, okay? And the 4th row of Pascal's triangle is 1... Shoot, I don't know. Oh, there it is. It's right there. 1, 4, 6. I think I did this wrong in my first class. 1, 4, 6, 4, 1. There we go. Okay, so you first start by writing those all out, and then the 5x will be to the 4th power, and then 5x is cubed, and 5x is squared, and 5x. And then 3y to the 4th. 3y, wow, to the 3rd, and there's pluses in the middle of all these. And this is 3y squared, and then this is 3y, and there's no 3y there. Sorry, this is so messy. I ran out of room. And then what you want to do is you want to do 5 to the 4th. Can you read that, Matthew?
No.
Sorry. Whoopsies. All right, 5 to the 4th is 625. So I get 625x to the 4th plus the next one I have to do. Do you see all those numbers I have to multiply together? I have to multiply 4 times what? 5 cubed and then times 3. Oops. And I get 1,500. 1,500 x cubed y. Okay, and then the next one, 6 times 5 squared times 3 squared is 1,350. And now x is squared and y is squared, okay? I'm not going to finish it, so you can see what happens. Now, if there's a minus in the middle of that, you alternate, positive, negative, positive, negative. Okay, the other type of question that we did in that chapter, we didn't do much. We just learned how to expand, and that was pretty much it. But the other one that we did was if you were given something like 2x minus 3y to the 19th power. Okay, I would never make you expand that whole thing, but I could ask you for one term. I could ask you to find the coefficient a for the x to the 16th y cubed term. Okay? Remember doing these?
Yeah.
You had them on your last quiz, yeah? Good. Okay, so you would do 19C3. 19 is this number, it goes in front. 3 is the second number. And then this would be 2x to the 16th and negative 3y to the 3rd. And so when you want to find this number, it's going to be huge. They're going to write it in scientific notation. 19C3 times 2 to the 16th times negative 3 cubed, and that'll give you x to the 16th y cubed, and you want to figure out what number that is. And it turns out to be super big. So 19, remember where that C thing is? It's under Math PRB. 19C3 is 969 times 2 to the 16th, and then times negative 3 to the 3rd. Whoa. Negative 1714618 ooh, I use bigger numbers in my other class. 68. X to the 16th y cubed. That would be it. Yeah?
Are the problems like this always NCR?
Yes. Yep, they are. Okay, all right, so that was 9-2. Whoa. 9-3 and 9-4 were the ones that went together. And those were about sequences and series. Sequence, series. Okay? So sequences, those are numbers in a row with commas, and series is a summation of numbers. You add them in between. And we focus mostly on arithmetic and geometric, right? So arithmetic, those are going to be our linear explicit formulas, and geometric is exponential. So if I ask you to do something like this, sum up the numbers from n equals 3 to 5 for n cubed plus 1. Okay, you can't use a sum formula for that because your sum formulas are arithmetic and geometric. Arithmetic's linear, geometric's exponential. What is this explicit formula? Starts with a C. Cubic. Thank you. It is. It's cubic. Okay, bless you. So, how do you do this? Well, some of you guys have a little sigma button on your calculator and you just plug it in, right? How do you guys do that? Yes? That's fine. It's okay. I'm okay with that. But if you don't, you can take this and plug it in. 3 cubed is 27 plus 1 is 28. Plus 4 cubed is 64 plus 1 is 65. And you have your calculator. You don't need to do that in your head or anything. And then 5 cubed is 125 plus 1 is 126. And then you go ahead and you add them up. Okay? And I won't do that many numbers because some of you don't have a calculator that will handle that, or you don't know how to use your calculator in that sense. But there won't be too many. And you just add them up and you're done. Okay? Now, if it's a lot of numbers, then you're probably going to expect that I would not ask you to add up, for example, 30 numbers. Okay, 2n plus 3. All right, I'm not going to ask you to plug the 1 in, then plug 2 in, then plug 3 in. No, I would never do that. There's a formula that you can use here. This is arithmetic, and the sum of an arithmetic formula is n over 2 times a sub 1 plus a sub n. So, n over 2, so there's 30 numbers over 2. The first number is to plug 1 into your formula, which gives me 5. And my last number is to plug 30 in, which gives me 63. And then you figure out what that is.
Could you write the sigma sign instead of sum?
For this?
Yeah.
Well, no, because it's given to you on your paper as s sub n equals n over 2. a sub 1 plus a sub n.
Yeah.
This works for this because this is arithmetic.
Yeah, I'm just saying that could you write it like with
Oh.
sigma? Because doesn't sigma just mean summa?
Yeah, but it's the sum formula. They change it to s.
Okay.
But yeah, like in calculus, that sigma ends up turning, or s turns into sigma, and yeah. My sister was looking at your guys' quizzes yesterday when she was over at my house. They were sitting on my table because I was grading them. She's like, what is this? Like, it looked Greek to her, and it is Greek, so it's kind of funny. Yeah, she never took this class. The highest she went was Algebra 2. So, there you go. Shout out to Donna and her math skills. Okay.
And she's the pretty one?
She's the pretty one, yes. Okay, we look the same. All right, so here we go. Now, you might have to find some arithmetic explicit formulas, geometric explicit, they're all going to be on there, all the formulas, okay? Divergent, convergent. Divergent, convergent. So, it's interesting. All right, so let's say you have something like n plus 1 over 4n minus 5. Does that sequence converge or diverge? And how can you tell? And if it does converge, what does it converge to? And all that good stuff, okay? Now, what I like to think of is I like to think of these as functions, and you have a horizontal asymptote, okay? And if I had a horizontal asymptote here, my asymptote would be what? Anybody? 1/4. So this converges to 1/4. Okay? As you go on, your numbers are going to converge to 1/4. All right. Know how to write something in sigma notation. So like, for example, if I had 5 plus 7 plus 9, bless you, plus ... plus 99. And I asked you to write that in sigma notation. Would you be able to? Yeah. You just had one of those, right? On your quiz? Okay. So sigma notation, make it easy for yourself. Just start at 1. Figure out what type of sequence or series this is. Sorry, it's a series. Find out what type it is. What type is it? Arithmetic. You're adding 2 each time. So the arithmetic formula would be
3 plus 2n.
Perfect. Ooh, that was quick. Jonathan, quick. 3 plus 2n, or 2n plus 3 if you want to write it like that. That's fine. Okay. Did you use the a sub 0 formula? Me too. That's my favorite. Jinx. All right, 2n plus 3 equals 99. All right. So I take the last number and I set it equal to my explicit formula to find out what n is. N's the number that's going to go up top here. So I subtract 3.
Why is 3 your first term?
It's a sub 0. No.
Yeah. So the formula,
Okay.
a
Got it.
sub, yeah. Okay. And then 96 divided by 2 is what? 43?
No, 48.
48?
There you go.
There you go.
Back at the mirror.
I know, right? 48. Okay, and if I ask you to find the sum of this, you can either plug it into your calculator. Once you have sigma notation and you know how to use that button on your calculator, you could plug that in. Or you would do the sum formula for arithmetic, which would be the number of terms divided by 2. The first term was 5, if you look up in the series, and the last term was 99. Put that in your calculator. Beep, boop, beep, boop. Turn the sound off, and there's your answer. Okay, and then from 9.5, the last lesson of the chapter, you will have to do a proof by induction. You don't like those? Yeah, some of you guys, they're like super easy now, huh? Some of us are struggling. Should we do one just to practice? Yeah. There's too many steps. There's only 3. They just take a while. You're right, they do.
Sometimes I just get confused on like the k plus 1 because if you have like k plus 1, but then it's like 4k.
Yes. You know what? I'm going to do the extra credit that some of you guys thought you got right, but you didn't. This was number 14. So you guys had 2 problems to do, 14 and 15. And on that assignment, I gave you 8 points possible, but a lot of you guys got 6 out of 4 because you didn't do 14 right, or you didn't show enough. So let me show you. Number 14 is 1 plus 2 plus 2 squared plus ... 2 to the n minus 1 equals 2 to the n minus 1. First of all, that is a crazy formula. That's pretty awesome, right? Okay, so here we go. We're going to go through all 3 steps. Step number 1, show that the sum of one number works. So the sum of the first number is 1, and then 2 to the 1 minus 1 is also 1. So yeah, you have to show this side and that side. You can't just write S1 equals 1. That's not showing both sides are equal to each other. Number 2, you have to write these 2 words. Some of you want to skip that for some reason. Maybe you don't think math we have words, but we do. Assume true. You have to assume this is true for a different variable. We use k, you can use whatever variable you want. 2 to the k minus 1 equals 2 to the k minus 1. Assume true. Step number 3, now we have to do the k plus 1 term. We're going to go 1 plus 2 squared all the way to 2 to the k minus 1. We're going to add the next term on, which is 2 to the k plus 1 minus 1. You change this k right here to k plus 1. And this is equal to 2 to the k plus 1 minus 1. All right, so that's not hard, right? Those 3 things so far, we're okay. You guys get used to doing them. And now we need to take this whole thing and replace it by what we said was we assumed to be true. So 2 to the k minus 1 plus, this is just 2 to the k. We have to show this is equal. And some of you guys went straight to saying that they were equal, but you didn't tell me why. You wrote 2 to the k plus 1 minus 1 equals 2 to the k, but you didn't show anything, okay? So I did not believe you, no offense. But if you do this, 2 to the k, and you rewrite it as 2 to the k plus 2 to the k minus 1, and if you know that if you have one 2 to the k plus a second 2 to the k, how many 2 to the k's do you have? You have 2 to the k's, right? And this is 2 to the 1. And what do you do when you have the same base to your exponents? You add them. And that's the trick step on this problem. And that's how they're equal to each other.
Wait,
So
it makes that one positive?
which one?
Oh, whoa.
It makes...
You still need
Oh,
2k
okay.
plus 1 minus 1.
Uh-huh, I have it. So if you have 2 to the k plus another 2 to the k, you have 2 to the k's.
Yes, but what about...
And I combined those.
In the transfer part, is the where's the 2k plus 1 minus 1? In the step where you transferred or you
Oh, yeah, it's right here.
substituted? Yes, but then the last part should be...
Because you substituted because...
No, I'm good. Okay, so I needed to see that step. I needed to see that you grouped them together at least, and you knew that that was equal to each other. So that's induction.
Can I keep this?